It's a pleasure to have you all here for our next session, which is Cooling the AI Revolution, an executive panel on thermal management for MENA's billion token data centers. My name is Matt Welsh, and of course will be the moderator here. And just as a bit of housekeeping, if you pop the headphones on and they are on and you see channel 0, you will be able to hear us clearly. We'll just test. If you have any issues, you plug it in, turn the power button on, and if you see 0, it will be fine. No?
And this is working?
That's working.
Is this working?
Yes, that is working, yes. And you can hear me now, and you can check, I can hear. Yes, I can hear, perfect. Great, with the small technical difficulties out of the way, let's begin. This panel is all about exploring how next generation cooling innovations, and be it liquid and hybrid systems to sustainable water strategies, and how they can enable AI-driven, high-density data centers to thrive within the MENA region. We have a lot to cover. I hope we get to all of it, and I'd love to begin by just kind of setting the scene and establishing where we are at within the industry. And so if I can turn to my first speaker on the left of me, Mohanad, may I ask you, where is MENA pulling ahead of global markets when it comes to AI-driven data center development, and where does it still face, shall we say, structural gaps?
Thank you very much for having me. Glad to be here, glad to be in Riyadh, and I see lots of familiar faces, so a very friendly crowd. Let me just say, I've been with Johnson Controls Arabia here in Saudi for the past 15 years, and been witnessing the evolution or revolutions that's taking place when it comes to data-driven technologies as a result of the investments and the advanced AI infrastructures that exist within the kingdom. So today, if we look at Saudi makes about 60 to 70% of data centers available now in the entire Middle East region. We are ranked number 5 in the world when it comes to the advancements and the growth in data centers in the past 8 years. Put that into right numbers, we have now about 300 megawatts of data centers already built, with the forecast of that growing at almost 29% CAGR year over year for the next 10 years or so. That's huge level of expansions that we're not seeing in any other sectors in the kingdom. When you look at Vision 2030, out of the 96 targets, 96 objectives of Vision 2030, 66 actually have to do with data. Mm-hmm. So just put that also, give an example. In Saudi, today there are 12,000 factories since the inception of Saudi. Based on the National Industrialization Strategy, the government is planning to build additional 13,000 factories in the next 10 years. And this is only manufacturing. If you look in banking, if you look in real estate, we are in the building technology business. And if I could share the details of how much data are being generated from buildings, the number is quite it's mind-boggling, really, and how you're going to have to deal. And we talk about data. When I talk about data, let's not forget. It's data, information, knowledge, and wisdom. And yes, data will generate so much, but then the AI around it, and how do you transform the knowledge to wisdom, and that will of course, creates lots of demands on data centers, much greater than what we've seen already.
If I can just stick with you, and then I'll turn to Imran, and we'll work our way down the panel. The title of this session includes the phrase billion token data centers. So for, let's say, the uninitiated, what does this mean, and how is tokenization changing how we think about compute, efficiency, and also investment within the data center space?
Well, I'd like Imran to answer the technical part of that from a data center's technology point of view. But what I can tell you, our technology, when it comes to data center, when it comes to tokenizations, what we're talking about here is, for the right technology, you'll get the right level of tokenizations. If you get sub-optimized system, then that will affect the throughput of your data centers. And it's an area of a great concerns, because we're talking about technology and the changes in technology. We've seen that the dependency on air cooled technology will not live up to the expectations of data center operators and owners. And I'm sure Umran will be talking more about liquid coolings and the needs to employ more technologies to deal with that, because it will ensure the right efficiencies and the right throughput of data centers.
Well, Imran, your name's come up a few times there. If I could throw the question to you and maybe go into that technical side of things that we just heard.
Absolutely. I mean, everybody's talking AI. It's just not talk of the town right now. So I'm here for the last 72 hours in the kingdom, and I've already met close to maybe a dozen, possible customers. And the first thing that I was asked that if AI is going to take the jobs away. And my answer was no, obviously, this is not going to happen. However, the air conditioning bills in the data center might do that. So this is how important cooling is. And obviously, so about 15 years ago, I built one of the fastest supercomputers in the world in New York that actually helped, this groundbreaking discovery of this God particle, which was a groundbreaking in physics, and learning a lot of lessons from there. And as we talk about tokenization, I mean, that was a 700 teraflop compute power at that time, which was size of a room. Imagine we can shove all of that in half of a rack. I mean, this is what's called progress, right? So tokenization is really important. In fact, it's the currency of AI right now. So AI is being measured in tokens. We never saw that before. And obviously, having a robust and efficient cooling system is important, because we can't really do anything with the consumption of the power on the IT side. These GPUs with this growing thermal design power is only increasing. We're seeing the chip's density going into 2000 watts now. The NVIDIA announcement with this Vera Rubin and the next Kyber architecture is going to be close to 3000 watts per chip. This is massive. And we know air has, by thermodynamics, by physics principles, it has limitations. It can't just cool a chip which is so powerful, so hot. So this is where liquid cooling comes into place. So liquid cooling is not a choice anymore. It is the need of the hour. By design, liquid cooling is needed. And how this is going to affect tokenization is by really understanding how much utilization we can have from an AI hardware for the lowest amount of power. This brings up an important discussion about having this metric called tokens per joule. This is a metric which has been talked a lot in the industry. In fact, a lot of hyperscalers and co-locations are actually charging their customers based on the numbers of tokens produced. So this is going to be a real important metric, and setting the tone or having the context of this within the GCC of the Gulf region, I think this is important. Saudi Arabia is going to be the hub of AI innovation, as Dr. Mohanad had pointed out. This is really big in the region. We're talking about the expansion, which is totally unprecedented. We have not seen this before. The gigawatt data centers are being announced. They may not be built by next year, by 2030. There's going to be an AI revolution in this country, and the infrastructure needs to be available right now. So I see tokenization is really important. So having that entire supply chain of liquid cooling will be the key. And I say this from the manufacturing, integration, and more importantly, serviceability. And this is where JCI is investing. We are heavily investing in all these three aspects, providing end-to-end solutions. And I said service is very important, which is going to help this kingdom and GCC in general, help move forward in producing trillions of these tokens.
If I can stick with you briefly, and then of course I will move on to our next topic and bring in our friends in here, Suman and Mohammed. But Imran, me and you, we've worked together before, certainly in North America at some other events. I'd love to just ask then, because you're from the North America, you've been able to travel and see different regions. What lessons from the US and perhaps even Europe do translate well to the Middle East, and which assumptions break down when applied to this region's climate, combined with its scale and of course the growth trajectory?
I think it's a great question. I don't think we have enough time to answer most of it, but I'm just going to talk about the gist of it. So I think speed is the name of the game here in the data centers. Speed matters, so is efficiency. We are seeing that, I don't know if any of you have seen this post from Meta. They were building data center in these tents, right? Portable tents. So that was a message to the industry. I know Jeff has nodded his head. He was working for Meta. It's really important to understand that how speed matters in this business. The GPUs really is the key because the AI models are getting double, triple, quadrupled in size within 3 to 6 months. Moore's law is dead. Moore's law really helped us for many years, but it is dead right now because the AI, let it be generative AI, whether it is agentic AI or it is a simulation, it is taken everybody by surprise because of the amount of compute power it is required to do a computation. So the lesson learned are really, the speed matters in this business, so lots of modularity is coming into play. Maybe 3 years may be a very long time for a greenfield data center to be built, for example. So modularity is very important. We're seeing lots of modular data centers being built. And obviously getting the key people involved, like JCI, for example, in the design process from inception, I think is the key. As we are seeing, what people are talking about, warm water cooling, which we know is not entirely possible because chillers is the backbone of this industry. And we know how much chillers can affect the throughput of the computing, hence the tokenization as well. So I guess 3 main points: scale, and speed to build a data center, modularity. Getting the key people involved in the process is really important. And more importantly, build something which is going to last for at least 10 years. So being robust, being proactive in the design approach.
Thank you. And I guess we'll move on maybe to the next session, because of course with all this rapid growth and this exciting technology, there's new challenges but also new opportunities that are in play for thermal management within AI-driven data centers. So Mehend, if we were to think about the hurdles that maybe some operators or developers face within this region, if you had to prioritize one constraint that most limits high-density AI data centers in MENA today, what would that be and why? Well, you're welcome to comment your thoughts. I'd love to hear them.
Experimentation. So the solution availability, right, use cases and operability of the use case is super good, right? In addition to time to market, and the second most important thing is the technology. We were talking about 100 kilowatt rack densities, right? Today, we are already at 200, and Nvidia last year declared 600, right? So it is changing very, very fast. So, and the infrastructure is built for 20 years, 25 years, right? Now, you cannot scrap the infrastructure and rebuild it again, right? It costs millions of dollars, billions of dollars, right? So how adaptable the solution is and how we are accommodating the change in the technology is also one of the key. In continuation to the third point, which I wanted to bring to this forum, like Imran said, bring people like JCI in, right? It is also important that we also look at the integration part of this, right? Tokenization can be leveraged only when we have an integrated approach, right? We know the system in and out. We have got every data available. We leverage those data points and integrate those in order to achieve better efficiencies. So cooling equipment is not independently working as a cooling equipment, but it is an integrated infrastructure.
Thank you. And Mohammed, having listened to some of our fellow guest speakers here in their discussion, do you have any comments you would like to add, or would you like a new question? And well, I'm happy to give you that as well.
Let me comment first. So a couple of things I want to connect the tokenization with the economical model. Saudi Arabia has been the energy well for the world from last 70 years, and it's going to continue to do so. But the value addition is coming to the tokenization. I did an exercise a couple of months back, and probably the numbers has changed by now. If you sell 1 barrel of oil for $80, $70 per barrel, instead of selling that oil, you convert that into X kilowatt hours of energy, and then convert that X kilowatt of energy into Y number of tokens, the value addition increases from $80 to $29,000. That's the economics of this all rush, which we are sitting here. Now, when it comes to the data center, PUE is a metric that has been driving the designs from last 20 years, which means that anything which is beyond the IT use is considered above one metric of one. If we have a PUE 1.6, which means we are using 100% energy for the IT, but we are using 60% additional energy for cooling, for lighting and everything. And most of that 60% goes to the cooling. So if the cooling is efficient, we can reduce that 60% by another 30% or 50%, which means you can go 1.3. And that is the OPEX of the game. And more data centers being built, the more efficiently, more effectively, and more available cooling systems are in place. That is going to drive a reliable business model out of these data center or AI factories.
I'd love to throw this question out to all of our panelists here, but perhaps I can also direct it to you, just because you're sitting next to me. I mean, with extreme temperatures and extreme densities, operational risks do you see emerging around uptime, maintenance, and SLAs that perhaps didn't exist 2 or 5 years ago?
Great question. Thank you. I think my colleagues here talked about this. When we talk about data centers, we're talking about wall-to-wall integrated solutions and also integrated maintenance, integrated uptime throughout the cycle. The issue is not specific to Saudi. Globally, there is a shortage of intellectual resources to deal with data centers, from the design phase, from the manufacturing, from the maintenance, throughout the cycle. And what we've been able to do here in the kingdom is to localize. I think it helped us. The ambient temperatures, somehow, if you're talking about from the cooling side, the temperatures here helped us to develop indigenous knowledge within the kingdom. I mean, Imran talked about this. We have almost 3,000 people working for the company inside Saudi Arabia. We do have a manufacturing facility that manufactures technologies that to do with the data centers. We have also the aftermarket capabilities. We have almost the second or third largest aftermarket operations for Johnson Controls globally in Saudi, and it's the largest in the Middle East. Those type of enablers can be enablers and also can be a challenge for data centers operators. I mean, yes, you could develop, you could design, engineer, and then deliver, and then have challenges to commission and start up technologies or maintain those technologies. It's a real challenge here, especially what we talked about, the expansions expected in the next 4 or 5 years will put lots of pressure on the entire ecosystem here. And we work together, set expectations, build relationships, attend such conferences to meet and make sure that we collectively are able to meet the expected demand that we see.
So, man, when we think about challenges in thermal management and AI-driven data centers, from a co-location perspective, where do you think the largest trade-offs are today? Speed to market, density, local compliance, when we are scaling large AI-ready projects?
Of course, the densities are playing critical roles, right? And the new and the technology supporting I no more call it as cooling the data center. It is removing the heat out. Cooling was 20 degrees, 22 degrees. Now we are talking about 30 degrees. It's by no standard is cooling.
The word's outdated slightly,
yeah.
Yes.
So we'll rephrase. So heat removal is super critical. And you know and how efficiently are we able to remove the heat? That is the key, right? So if you have to really do a trade-off, right? I think we cannot do a trade-off on the efficiency by which the heat can be removed from the data center, and therefore we need technology support, technology updation, and technology from the infrastructure side matching the pace of the developments happening in the silicon.
I think that leads us very nicely on to our next topic, which will all be about those opportunities and innovations within thermal solutions, be it efficient cooling, if we like that word still, modular infrastructure, and of course sustainability. Mohammed, when you come across in your day-to-day work, which cooling approaches do you think are delivering measurable gains today with regards to speed, efficiency, or which do you see are perhaps a little too experimental at this stage?
I don't think it's experimental. The industry has been out there and been testing these cooling technologies from long period of time. It's the climate dependent. For example, if we have the opportunity to have evaporative cooling. There's plenty of fresh water available. That's one aspect. If we are in a deserted area like Riyadh and around, then probably the air cooling air cooled chillers is the only viable option to work with that. And then when it comes to the inside data center white space, the predominant cooling systems, which is driven definitely again by NVIDIA, is cold plate along with the air cooling. So it's a mix of hybrid cooling solution, a cold plate and air cooling, and these are the ones which are out there, which have been now deployed at. The projects under our review as Uptime Institute are over 2 gigawatt of liquid cooling in place. The challenge or the key thing that is important here is to understand when we were using only air cooling inside the white space, there was a thermal sink available that can support if there's a failure, if there is something unplanned happen on the facility, there was a couple of minutes to react to that. Now with the cold plate and the TDPs reaching 2000 watts and above, it's less than seconds time before it's going to throttle or fry the chip, which means the concurrent maintainability, fault tolerance of these cooling solutions properly engineered in the facility becomes more and more critical.
Imran, it looks like you have a comment as well.
So it's a great segue, I think. The way I see the opportunities and the painstake in this industry is really, we need to take a look at this data center ecosystem at a system level. I was just talking to people, wouldn't mention any name, they're like, what are your thoughts on immersion cooling? I mean, I have my say on that, obviously. Not to just let anybody down, obviously, with almost like a menu of cooling options available these days, from single phase direct to chip 2-phase, obviously hybrid, and immersion is also out there. I mean, there's no such thing like one size is going to fit all. There's no such thing like that. If you're in a co-location environment, you might have enterprise computing, which has no GPUs, for example. Maybe air cooling is the right choice. Meanwhile, within the same data hall, you have a GB300 NVL72 GPU, which is going to be producing lots of heat, right? Requiring liquid cooling. I think the understanding is where every single element, for the most part, in this ecosystem in the data center is IoT enabled, meaning that it is capable of taking the data in and out of it, right? So we can easily extract the telemetry from the node itself, the IT itself. So I guess what I'm trying to say is that the IT and the OT aspect of things are really important. This is where the opportunity is, and integrating all the data coming from all the end devices, and then using AI, machine learning algorithms to really enhance and find that sweet spot where the opportunities. For example, if we talk about an inference workload, it's going to go up and it's going to go down. It's not a constant heat load. The cooling system are not responding as fast. So this is where the opportunity is, and we know cooling accounts for about 30 to 40% of the energy cost. And this is what I will say, every watt spent on cooling is a watt not spent on compute. This is how I put it.
If I could just ask you a question, and then Soman, I'll have you jump in as well, because this next question involves the word token, and that's what you talked about earlier. So obviously, from your perspective, when we are talking about operators, where do you think they are seeing real efficiency in their gains that allow the higher AI and the token output, which without proportionally increasing power consumption?
So this is, again, a great question, and we know that chips generally like to be run cooler. And this is by physics, right? So most of us know clock speed, right? Which is a function of frequency and voltage. So what happens is, if the chips are going to be running warmer, the clock speed goes down, hence the tokenization. Less tokens are going to be produced if the GPU is in a thermal throttling mode. So tokens are going to be produced less. But there is a theory out there without mentioning anybody's name here, that a lot of people are thinking about warm water cooling, so so that more tokens can be produced. I just want to bring a point here, which I think is really important in the current context of things. So imagine there's a data center which is 100 megawatts, for example. It is going to be producing, let's say, 50 million tokens, for example, in a month. And it is consuming about 40% power, 40 megawatt of power on cooling systems, for example, right? So now if we go with warm water cooling, what's going to happen is that that 40 megawatt of power which is going towards for cooling is going to cut down to by maybe 10 megawatt, almost a 70% decrease in power. But that power is going to go back to compute, hence producing more tokens. However, the tokens per GPU or CPU is going to be less. So this is a real important issue which needs to be understood, that GPUs tend to run better. So there is a pure physics principle that for every 10-degree rise of a junction temperature, the GPU efficiency or the tokenization goes down by 30 to 40%. So I think understanding this metric of tokens per joules, tokens per TCO is really important. And as I said before, it's just not so somebody who's saying hearsay or theresay. It is actually being implemented, and this is something where the industry needs to collaborate. And as Dr. Mohanad has said, we need to have a thought leadership developed here in the kingdom, where we talk about all such issues in all these forums. Maybe you want to do another session, Matt, in Jeddah or something, so we can bring more thought leaders and talk about how we can really understand the effects of cooling on tokenization.
Amazing. If I could ask for Soman to have his final word. Imran, would you mind just passing the mic out just for a quick one? And then, of course, I think this will round out this section before I turn back to Dr. Mohanad, and we'll talk about the last few minutes. But you have a comment.
No, so I completely concur with what Imran was saying. So one is to identify the right throughput or right temperature at which a right throughput can be generated. And second important thing is, once we know, right, we map these data points, right? Because mechanical system cannot react at the pace at which the chip is consuming power or operating, right? And if this mapping can be put into a model, right, which can machine learn, and then all the equipment, right, within the mechanical system or within the set of infrastructure, which is actually delivering the optimal efficiency, is put into an automation mode, right? I think that's the key, because then we achieve two things. One, we are operating the chip at the right temperature at which we want to operate, and second, leveraging the data points which are available, right, in making the infrastructure more efficient and consume less power. So that makes tokenization more efficient.
If we can have a brief comment as well, and then we can move on.
Well, this is what I call floating set points. And Imran and I have been working on this concept from last many years, that depending on the outside temperature, the inside workload, we can have the floating set points of the chillers, secondary chilled water loop, primary chilled water loop, and the cooling system inside the white space to perform optimum that can help to optimum performance of the GPUs and CPUs, but also the optimum efficient performance of cooling.
Thank you. So I always like to end the sessions looking forward into the future. So if I could turn to you, Dr. Mohanad, I know you won't have a crystal ball in front of you, but over the next 12 or 24 months, what concrete changes do you think we could expect in how AI data centers are designed, built, or operated within MENA?
I'll tell you, they say all politics are local. And when it comes to technology, I'm telling you, all technologies are local. Imran spoke about IT and OT. I mean, we have developed the operational technologies. We manufactured them here in the kingdom. We use, as a company, we used to import 70% what we sell in Saudi about 4 years ago. Today, we're manufacturing 70% of what we sell in Saudi, and the aim is actually to move to that 100% by next year. This has been a great enabler for us to meet the expected demand. I mean, we've seen that in certain aspect of the technology, there is a stress on suppliers or manufacturers globally. So if we want to be successful in Saudi, we need to really, I mean, it's a government mandate, by the way. Vision 2030 is quite clear. Part of it is localization. And when I talk about localization, I'm talking about the manufacturing part, the IT part, the entire ecosystem around it. And data center owners, I know they want a reliable partner. So they want a single stop shop that they could communicate with. And therefore, when we talk to partners and we communicate with different players, this is the number one issue that keeps me engaged. I mean, and you talk to our partner in the STC, you talk to our partners in Data Vault, you talk to our partners, how can you serve me and serve me now? And this is really I think what will determine the future of this industry in the next 12 months. How much of that knowledge is locally available, how much of that knowledge can be disseminated in a real-time environment to meet the expected demand. And this session is just one good example of that. Thank you.
I think I have time for one more question for you, Imran, and then what I will do is I will ask for our final key takeaways, beginning with you, Mohammed, and we'll work our way back to me. So the final question is, what do you think are the emerging trends or technologies that the co-location operators should be watching out for in the next few months?
Well, I think it's a difficult one to ask because, as I said, there's too many technologies out there. But if we see NVIDIA's roadmap, right? Surprisingly, they have single-phase direct-to-chip cooling deployed for the next 3 generations of GPUs coming, which is going to be a megawatt rack. So the key thing here is understanding a robust design technology, which is going to serve all kinds of workload, not just liquid cooling. Liquid cooling obviously is going to be, the most prevalent and most deployed technology, but having that robustness within the design and deployment, so you can adapt and you can be in the business having more ROI, from your co-location, from your enterprise computing locations for your customers. Just adding to what Dr. Mohanad has said, I just joined JCI literally a few months ago, and I'm really happy, and thanks to the hospitality here as well. I have seen something while I was visiting the Jeddah factory a couple of days ago. It's really amazing what the potential is. And I think speaking of the expansion, which is going to be in gigawatts in the next couple of years, it's really important to have that end-to-end solution. And more importantly, the serviceability of these things. You can buy the most expensive GPU in the world. What if it's just going to go down because cooling went down? You need to have the response within like minutes. And this is where JCI comes into play, to meet with all those challenges.
So we have a few moments left. What I'd love to do is, as we close out here, begin with some final thoughts. So obviously we never could get to everything in just 35 minutes, but Mohammed, what would your final key takeaway be for the audience here today?
So my key takeaways are efficient, available, and flexible cooling solutions for data center is the future, which is going to keep these data centers running for next 15, 20 years.
Thank you. And Sohan?
Yeah, so in continuation to this, I think templatization and building ecosystem around the template, right? Whether it is serviceability or it is productization, I think that is also going to help achieve faster time to market.
Super. And of course, Imran, what would your final thought be?
I think being open-minded is the key as we build, data center which are totally going to be, looking something really unique in the next few years, and being able to collaborate. This industry is all about collaboration. This is one way we can solve the challenges. And the key thing I always say is the system level understanding. This is where the opportunity is. There's a lot of talk about this. Controls is going to play a very vital role in optimizing power, which is a conundrum these days to solve these challenges. So collaboration and controls is the key.
And Dr. Mohanad, to close us out today, what would your final thought be?
We have received about 10,000 visitors to our manufacturing facility in King Abdullah Economic City in the past 4 years. An invitation to the audience to come and visit us. We're looking for partners to actually build. I mean, we already have a data-enabled technology center within the facility. So we're looking for partners also to show off their technology in that center. And I'm quite serious. If interested, please do come visit us. And the partnerships that we get is what makes us all stronger. So thank you very much.
And thank you to our guests, and please join me with a round of applause.